So today's class we are going to discuss about the generator functions. So normal def function always starts with a word called def. That is called a keyword in the Python. So when I say def means it's a normal function. Lambda means that is also one of the keyword in Java in Python. Okay, so that is called lambda inline functions or lambda anonymous functions. But generator functions also start with def only. From the syntax point of view, there is a very small difference between the normal def statement or function or generator function and generator function. Lambda is completely different because it's a word is a lambda and it have only single expression statement inside the body of the lambda function and etc. Its total purpose is different, look wise is different, syntax is also different. But a normal function and generator function almost look like the same. A very small difference is there. For example, I have defined, okay, a function. Let us just copy this function to save our time. Let me open the Jupyter notebook. Okay, so here I'm just copying the function. This is my normal function. Okay, so here def followed by the name of the function followed by the parenthesis which contains how many number of arguments I need to pass to this function. Here I'm just passing only one argument whose name is equal to n. So this is my function definition. This is all my function definition. So I'm just going to call this function here build squares of, for example, 5. So what it means, this function is going to call the this function definition, and this is the code present in it. What this code is saying is, when I say 5, what is the successive integers of the 5 starting from 0, 0, 1, 2, 3, 4, excluding the 5. Okay. So for those numbers, it is going to this function is going to build the squares of each and every number: 0 square, 1 square, 2 square, 3 square, and 4 square, and preparing them entire in a list and returning the list. That's what this function is doing for me. It's a normal def function, normal function. So what is the difference is between the normal function and generator function is the normal function is also having the generator function is also having the same def followed by the name of the function followed by how many number of arguments you want to pass, the same you can pass it, no problem. The only difference is this is the only difference. In case of normal functions, you are going to return some value using the return statement, or you can able to return multiple values, one value, that is up to your choice. Okay, so you can able to return some value using the return statement. If you are not having any return statement inside a normal function, Python by default is going to return the none value, no value. Okay, assuming that you are returning some value or multiple values, how you are going to return the single or multiple values in the normal function using the return statement. But in case of generator functions, okay, we are going to return the value from a generator function using the yield statement. There is a statement called yield. So here, normal functions, we are going to return the value using the return statement. In case of generator functions, we are going to return the value using the yield statement. That is the only clear and blunt indication whether the def statement is a normal function and this statement is a generator function. This is the only indication. There is no other remark or the other mark, other indication to differentiate this is a normal function or non-generator function. This is the only indication. If you are returning the value using the return statement, that is a normal function. If you are returning the value using the yield statement, that's a generator function. That is the only difference. Then what is the difference between the return and yield? Both are returning the values. Then what is the difference between these two? Okay. So just understand this point. For example, you went to America, for example, from here for a purpose. There is a one task for you in USA. You went to there from India to USA. Okay. So once you reach USA, what you do? Generally, what is the purpose you went there? That is a task. completion purpose. There is a task for you. You completed the task. And what you will do after the completion of that, you definitely comes back to India again. That's what we generally do. Whatever is the purpose we went there to USA to complete the task is completed. You went to there, coming back to India. So in this way, so once you complete the task, you are coming back to India. You never go to USA until the task. There is one more task for you in USA, right? So until you never go. But in case of, I'll just give you one more scenario. You are in India and you are going to USA to, for example, France. Of course, there is a task for you here also. Okay. And the task is divided into multiple tasks here. Let us say subtask 1, subtask 2, and subtask 3. And for example, up to subtask 8. 8 subtasks are there. Clear? And what is you have, there is one option for use. So once you come to France, you have to start with the subtask 1. And after completion, you have to go for subtask 2, 3, 4, etc. till 8. And you have to complete all the subtasks. And then coming back to India, there is one option to you. Clear? What is second option? You can also say you complete the task subtask 1, you coming back to India. So the subtask 2 is not ready to start. Clear? So until then, what you will do in France? There is nothing you can do in the France. So what you will do? You will come back to India. You stay in India for a few days. For let's say, like for example, 1 month or etc. When the subtask 2 is ready to start, you again go back to France and complete the second subtask 2. And you'll come back because to India because subtask 3 is not ready to start. Whenever it's ready to start, you'll come back to France again and do the subtask 3 and you come back to India because subtask next subtask 4 is not ready to start. You continue this process until the last subtask. This is also one option. So when we choose this option is whenever you complete the subtask 1 and subtask 2 is not ready to start and there is nothing you can do in the France, okay, you'll come back to India and you will wait in India and then whenever the subtask 2 is ready, you go back to France again to do the subtask 2. If this is the case, then you do the like this. If all the subtasks are, we can start immediately the one the previous task is completed. What we do, we go to the France and subtask 1 will complete. Immediately subtask 2 can be started. You will start the subtask 2 also. And so on, you keep on completing the subtask 8 and then completing all the subtasks coming back to India. In this case, you never choose to have option of okay, subtask 1 I complete. I'll go back India. I'll stay 1 day there. I'll come back in 1 day and complete the second, so start the second task 2. Because subtask 2 is ready to start as soon as you finish the subtask 1. There is no need to go back to India again for each and every task completion, right? You understand the difference between this scenario and this scenario? Similarly, this is a kind of return. Return means whatever the task you went there, your USA or France, you complete entire task and coming back. Once you come back, you never go back. Because there is no task for you to there. It's already done. You finished it. So that is what return will do. What yield will do is, so yield is going to also returning the from France to or from the function to the generator function to normal call. Okay. But there is a chance. There is definitely there is required. You need to go back to the function again and do something there again. Means like this. Subtask 1, you finished it. Coming back to India, you stay wait in India until the subtask 2 is ready. Once the subtask 2 is ready, you will be informed and you will just coming from India to France again to complete the subtask 2. It's an iterative process. In each and every iteration, you are just finishing the task, going back, and again you are coming to the task, finishing the task and going back, and so on until the last task, until the last run. Right? You understand this difference? Anyone have any questions here? So, because this is the basic general example that I have given to understand the yield. If you don't understand this concept, you cannot understand the yield. Anyone have any questions here? Yield? Okay. So now that is the only difference between the normal function and generator function. Normal function is going to return the value using the return statement, and generator function is going to return the value using the yield statement. Okay, but how it yield return is something like once you return the value, you never come back to the function until the function is being called. But in case of yield for a generator function, we are returning the value using the yield statement. So yield is something like, so the tasks are still pending there, and first you complete some portion of the task and coming back, you wait there and come you whenever it is required to go to the next task, you'll go there and complete the second task. Just keep on until the last subtask of the entire task. Okay, so now I am just going to build the same function using the generator function. So let us see. So I'm just giving some different name, gen squares. Here I'm just build squares is my function name, which is going to build the number of squares of the successive integers starting from 0 to the given number. Here also I'm just going to see, okay, for I'm just not y I e l d I to the power of 2. See here, this is my generator function. So why I'm saying it's a generator function? Because I am returning the value. I have a yield statement inside it. So I am returning the value using the yield statement. So hence I am calling it a generator function. Here also, the both the functions result is the same. There is no change. But here, this function I am calling is a normal function because I am returning the value using the return statement. So now, one point everyone should remember, whatever is the return value, what is the return value here? This is a list. See here, RES. RES is a list containing some elements. These are the elements. And this build square, whenever I call the build squares always return me a variable that is storing a list inside it. Okay. Similarly, one minute. Yeah. Similarly, so whenever I am just calling a generator function always returns the generator object. Generator function always return the generator object. So what is a generator object? Generator object, what is a list object? List object is a variable that contains the list object inside it. List object is something like this. Contains multiple elements inside it. So here, this generator function I am calling here, this function is always returning one object that is always a generator object. I am just saving inside generator object is called in a variable called my obj. Some variable I can give. So this is my calling the function. See here, when I'm just printing my obj, for example, just going back to the one, this build square is always getting my info. And I'm just printing my info. My info is going to print the whatever is the build squares function is returning, that is returning a list that is saved in the my info variable. My info in printing the list of the elements. That is good. We know this. So here also generator function is returning always the generator object. That object is saved in a variable called my underscore obj. I'm just printing the my object. See here, this is not contains the information of what is this result. This is nothing but a generator object. See here, generator is a type. Okay. So this is location where the memory this generator object is saved, and this generator object is generated because I am calling a gen squares generator function. Clear everyone, what is the notation? This notation is this my obj contains a generator object. What is the generator object? This is a generator type object which is saved inside a memory location. This is the location of the memory, and this is generated because of calling the gen squares generator function. So now I got the generator object. Now how do I know what is the values present in this generator object? Now understand that this is an empty generator object, doesn't have any values inside it. This is very much important, you should understand. This is how the generator functions, generator objects are going to work. Now, this generator, my obj, doesn't have any values inside it. Basically, what I am trying to do in the generator gen squares function, I have whatever is the number of successive integers starting from 0 to given number, I am building the squares of it. But now this generator doesn't object doesn't have any values inside, any elements inside. This is my expected result. So how to get the result? So when I say my obj dot next, not next, double underscore next, double underscore. We already seen this in the iteration. This is called iteration protocol. Any protocol that supports the double underscore next, double underscore, or built-in function called next. Anything is fine. Okay. So here I'm just using double underscore next, double underscore. So this generator object contains this method already, double underscore next, double underscore. What it will do? It is going to get the first element of this present in the generator object. At this point of time, this generator object is empty. No elements present in this generator object. So what value it is going to get? So as soon as we call the double underscore next double underscore or simply next function related to this generator object, now at this point of time, Python will go to this gen squares function. And what is the first iteration? I have just given a 5 here. This is how gen squares function have been called, and I am just sending the value of input 5. And because of calling this function, it is generating the generator object. This generator object is generated because of calling the gen squares generator function. So whenever I just call next my object dot double underscore next double underscore, Python immediately goes to this function since 5 is passed here. So for every iteration in the range of 5 means 0, comma 1 comma 1 comma 2 comma 3 comma 4. These are the 5 values it is going. So this loop is going to iterate 5 times. So every time what it is returning? 0 square first time. Second time 1 square, 2 square, 3 square, 4 square. Since we are calling the next first time here, this loop is going to start iterating now. This loop is going to start iterating now when we are calling the first time the next double underscore next double underscore method. Until I call this double underscore next double underscore method, this loop will not start iterating. That is very much important. Got it? So I'm just repeating, gen square is a generator function because it contains a yield statement. I am calling the generator function here and giving input as 5. Since the generator functions always gives the returns back the generator object, this generator object is saved in the myObj variable. Now this is a generator object. This generator object is an empty generator object, does not have any values inside it. Means the code present in this function is not yet started executing it. So when the code present in this generator function is going to start executing is whenever I am calling the first time double underscore next double underscore or next function also, anything is fine. So whenever I execute this calling the next function or method present in the generator object, now at that point Python is going to start executing the code. What is the code? This is a 5. So this loop is going to iterate 5 times. The first time iteration is going to get the value of 0, 0 square, 0. It is going to return the 0 here. So next time I'm calling, okay, so what it is doing? So the 0 is already get, the next element is 1 here in the n, range of n. So 1 square, 1. So next it I'm calling 2 square, 4. Again it is calling 3 square. So until I'm just calling a 1 by 1 next function or next method, the respective iteration is going to execute here. If I stop here, if I never call the next again on this generator object, this, yeah, so this 4 value will never, so 4 square 16 will never come. Now this generator object already extracted the data of 0 square, 1 square, 2 square and 3 square. And if I never call the next function on this myObj, the 4 square will never be yielded from this function. Means it is something like whenever you need it, then only you just get the value. Otherwise, if you don't call it, that will never give the value back to you. Clear everyone? Any questions here? It is something like I am just giving a normal and daily simple example here, actually. Okay. So the simple example is, let us take an example. For example, you have a football in your home. Okay. Some your friends are playing in the ground. Football is present in your home. Your friends are playing in the ground. Someone in the ground who is your friend called you and asked you to bring the football to ground so that they can play. Okay. So what you will do? You will simply just take the football from home to ground. It's a normal. We know that. For example, there is one more case. Okay. In a home, you are there. You have some cricket balls are there. Some, for example, 10 cricket balls. Your friends are in the ground. Okay. They are playing the cricket as a 10 teams. And what they ask you? Okay, I asked you, hey, you have 10 cricket balls. So we are playing the cricket as a different teams. You bring all the 10 cricket balls. At this time, what you will do? So it's very difficult for you to handle all the 10 cricket balls with the two hands. What you will do? You will take a bag, right? You will take a bag. In the bag, you place all these 10 cricket balls and you bring the bag to ground. That's a common, simple logic, right? For example, I'll just give you some special example now. In your home, there are 8 footballs. These are all footballs. Okay? 8 footballs. And at the same time, your friends are playing in the cricket, some ground, football ground. And what they ask you, hey, you have some 8 footballs in your home. You please bring all the footballs, we'll play. Then what you will do? Is it possible for you to handle all the 8 footballs with the two hands? Not possible. Since this ball is very small, cricket balls, you can easily pack the 10 cricket balls in a simple small bag and you carry the bag. That resolves your job, your task. You're done. So, but to place all these 8 footballs, you don't have a bag also because it's a football size is very big. So you cannot place all the 10 or 8 footballs in a single bag. So now what you will do? Can someone answer this question? It's a very general question. I'm not talking about any Python or any logic. So if this is the case happens to you, what you will do? You have to carry 8 footballs from home to ground. So now how you are going to carry these footballs?
We carry two football at a time.
2 footballs at a time. Okay. First, first 2 footballs you are going to carry and go to home, go to ground, and coming back. Okay. So
Yes,
again 2 footballs you are going to carry and going to ground and coming back. One more, 2 more footballs and 2 more footballs. That's what you are saying, right?
yes, yes.
Okay. Is there any other option anyone can have? This is also one of the good option. But do anyone have any other option? Any other options anyone have? If this situation comes to you, what you will do? Yeah, this is one of the good answer, good option. Obviously, everyone will do the same thing. Any other option anyone can do? Yeah, in fact, this is the only option we have. There is no other options. So either you carry 1 football or 2 football, whatever is convenient to you to carry at a time. You carry them, go to ground, place it there, and coming back with empty hands. You are coming back with empty hands, right? You are going there with 2 footballs, right? And coming back with empty hands, right?
Yes.
And again, taking 2 more footballs, going to ground with 2 footballs, and coming back with empty hands. So on until the last football is going to be placed on the ground, right? So
Yes.
this is the one same we are going to apply here also. Means first whenever this build gen squares. So first time, so this gen squares, what is how many elements are expected? There are five elements: 0, 1, 4, 9, 16. Okay. So here also, rather than footballs, I have a five elements called 0, 1, 4, 9, 16. Okay, five elements. So since these are the very small element, I have option of I have placing all these elements in a single list. I can send a list back. This is what I am doing here. So here I am just taking 10 cricket balls. Since the ball size is very small, I can easily pack them into a one bag. I can take the bag from here to ground. It's my simple job. But why we are choosing two footballs at a time to go to ground? Reason is that this football size is very huge. I
Yes, sir.
cannot accommodate 8 footballs in a single bag. That is why I am going to this option, two balls at a time. Similarly, for example, if I want to go two balls at a time, I can take one element at a time. What I can do, first I will take the first element and return it. And I'll go to the, whenever I call the next, double underscore next method, double underscore, then it will go to the next element. Take the next element, coming back here. Whenever I call the next element, method, then I go to the next element. It's keep on doing like this. If I don't call the next method here, it will only get the values of 0, 1, 4, and it will never take the values of 9 and 16. So means you have to take the value to the next element. You have to call the next method in the generator object. Is it clear, everyone? Any questions?
Yes, sir. Okay.
Okay. Okay. So that is how the generator functions are going to. But then what is the use of these generator functions? See, the same logic I'm just going to see as long as the data, whatever you are returning from the or information that you are returning from the function, that if there is very small data, then you can simply just pack all the data in the form of a list or a dictionary or a tuple, whatever is the one. You just pack it and send that entire package back to caller, right? If the data is very huge, if the data, whatever you are preparing using the function is very huge, then packing the data into one data structure called list or tuple or dictionary, that's a huge data you are going to pack, you are sending. So your memory RAM is not going to accommodate to prepare such a huge data. For example, your RAM is only 2 GB data. And you have such a data to pack or send back to caller, which is data is, for example, 3.4 GB data you are going to return from a function. So can 3.4 GB data can be prepared in a single object if your RAM is only just 2 GB RAM? Not possible. So obviously you're going to get an error that, hey, there's some memory error exception, you're going to get it out of memory. So what we can do? So this 3.4 GB data is going to be packed with some 1 million records, let us say, where each record or each data having a memory of, for example, value of, for example, 10 MB. So here what we are trying to do, we are first returning the first 10 MB element, coming back, again second 10 MB element, coming back, and so on, right? So your RAM is going to support here. Rather than returning 3.4 GB data, if you have your RAM is only 2 GB, which is not allowed, not possible, okay? Rather than returning the entire data of 3.4 GB, you are going to iterate or sending element by element from the generator function. Generator functions are always used whenever you want to return the value element by element rather than all the data together in one shot. So wherever it is possible for you to return the entire data in a single shot, you always go for the return statement on a normal function only. That is good. If that is not possible, if this is a scenario like 8 footballs, you cannot bring all the 8 footballs into ground from home because there is no such bag which can accommodate all the 8 footballs in a bag. Obviously, what you will do, you are going to, this is the only option. There is no other option for you. This is the only option. In such an option, you are going to take the football by football and going to ground, keep it there, coming back with the empty hands, taking one more football from the home and going to ground, place it there and say, this is the only option. There is no other option to you, right? So this is generator function always returns the value element by element as soon as you call the next function. Is it clear so far? So because of this, the memory also will be used very effectively. See, this is one of the example I just given the memory. Clear? So here also the memory will be maintained very effectively. So I am just using only 10 MB data, 10 MB RAM, not the 3.4 GB RAM. This required 3.4 GB RAM if I want to return the entire 3.4 GB data from a function. Because my RAM is only 2 GB RAM, which I cannot accommodate. So obviously I don't have any other option. I have to go for generator function where the each and every element of this 3.4 GB is a 10 MB. So I'm returning always 10 MB at a time, 10 MB first elements, second times and 10 MB and so on. So my RAM supports very good. Clear? Let us take one more example to understand the benefit of the generator functions. Okay. So let me just discard. Okay. So another function is, for example, I'm just taking one more example. Okay. So now in your home, okay, your brother and friends are playing in the ground. And what they ask you is, hey, we are almost 10 people are playing in the ground, me including the friends. You please bring the food for all the 10 people. We'll eat the food and we'll continue to play. That's what the people ask you. Okay. What you will do, you will say to mother, hey, mother, actually, my brother is asking food for the 10 people. You please prepare a carriage. Generally, in homes, we don't have a carriage of storing the food for 10 people, right? Generally, we are having for everyone, we have a carriage, food box. What will ask your mother? Okay, please prepare a food box for 10 people, each and every box for one person. So 10 boxes your mother is going to prepare. So if mother wants to prepare 10 boxes, let us say for each box, mother will take some 5 minutes to prepare. Means she has to basically keep some chapatis, keep some curries, keep some snacks inside each and every box, right? For every person. And it has to be packed properly. And that takes, for each box, it takes 5 minutes for your mother to pack the box. So here, if this is the scenario, what is the option? So you have to wait 10 boxes, means for every box, your mother is going to take 5 minutes to pack it. You have to wait for almost 5 into 10, 50 minutes you need to wait, right? 50 minutes you need to wait to take all the 10 boxes, to take all the 10 boxes to ground. Clear? So rather than this, I suggest one more option. See here. First, of course, here the difficulty is you have to wait for 50 minutes. Means till the 50 minutes, no one in the ground can able to eat something. Right? No one in the ground, your players, can eat something because the first carriage will be reaching them. All carriages are reaching them after the 10-15 minutes only. So then only they will start eating. The other option I have is, okay, so since my mother is going to take 5 minutes to arrange each and every carriage or food box, I will take as soon as my mother completes the first food box after 5 minutes. Okay, 5 minutes. I'm just going to take the one carriage, one box to ground and coming back with empty hands. So this going back and coming back is going to take, for example, 5 minutes of time, let us say. So by the time I go there with the first box and coming back with empty hands, my mother will prepare the second food box also. Because 5 minutes of time I spend in going back, going to ground and giving the box to the players and coming back to home. This took 5 minutes for me. So in this 5 minutes of time, my mother is going to arrange second box. Again, I'll take the second box, I'll go to the ground, okay, and coming back with empty hands. So this is again going to take 5 minutes of time. And by the time my mother is going to arrange third box. So like this, I can able to give 10 boxes to my players. Clear? So here,
So both offer is a time is a equal. So
yeah,
first time is
yes,
a
time
50
is
minutes
equal.
and yeah.
Correct. So here, the basically in this one also you are going to take 50 minutes of time. But the difference is that until the 50th minute is over, at least one player in the goat cannot eat anything, right? All the players, 10 players here, have to wait 50 minutes of the time to start their eating. You understand? But in this approach, at least the first player will wait for 5 minutes, second player will wait for 10 minutes, third player will wait for 15 minutes. So the last player only will wait for 50 minutes. You understand difference? Here all the 10 players are waiting for 50 minutes. Here only the 10th player is going to wait for 50 minutes. You understand the difference? For you, the taking back, coming back, so taking the entire food, the last food from home to ground, the time is the same, 50 minutes. Means here also you are going to wait for 50 minutes and taking the entire food to ground. Here also you are just working for 50 minutes. Yeah, from your perspective, there is no difference. But from the player's perspective, I am talking about the player's perspective. This is one option, this is other option. In the first option, all the players, 10 players have to wait for 50 minutes to eat the food. Here only the 10th player only has to wait for 50 minutes to eat the food. Clear? So this is one of the advantage in this second option. So I'm just relating the same one. So generator functions, the first option what we see, first advantage what is the memory is going to be used very effectively. And whenever the performance, the second is what we say performance actually. Performance means, okay. So here the time. Here the 10th player is only waiting for 50 minutes. The remaining all players are they are eating something. So by the time the 10th player receives the food, the first player, second player, third player already completes the food and they'll go to some action, right? So this is effectively using the time basically. Time for action is being used effectively by the Python program. These are the two advantages that we had with the generator functions. Wherever you need these two advantages, you want to use the memory of the data very effectively, or you want to use the time, the performance, the time of the program, so execution time very effectively, go for generator functions. In all other cases, go for normal functions. That is fine. Clear? Okay. So this is one major use of the generator functions. Now you understand how we are going to get element by element from the generator object using the double underscore next double underscore method present in the generator object. Okay. Now, so far we have seen the next method. Okay. So far we have seen the next method. So I'm just going to the code back. I can use generator object dot double underscore next double underscore. I can also use something like this, my obj, because the first element, second, third, fourth elements are already extracted. The fifth element, 4 square 16, is still pending. When I'm just calling using this next function, built-in next function, where I'm passing generator object, is going to return me the 16, the last element. If I still calling the next here, it is going to get the stop iteration error, because there is no elements to extract, because all the elements, whatever is required to extract from the generator object, they already extracted it. There is nothing to extract or nothing to return the value from the generator object. All the values present in generator object are already been extracted or returned. So this is the one that we have seen so far.